In this lecture, we are going to revisit the idea of invalidating pointers in objects you steal from through move semantics. If you remember what we did in the last few lectures, we set up a move constructor and a move assignment operator. And what these member functions were doing is basically stealing from the source parameter object that we have here. So we did steal the pointer using the line here, making our own items pointer point to the same thing the source is pointing to. And then after we do this, we stressed the idea of resetting the pointers in the source object so that when the source object tries to manipulate its mItems pointer, it won't be manipulating the pointer that belongs to us now. This is the idea here. So we did call an invalidate method, which was resetting the pointer for us. We did the same thing in our move assignment operator. We stolen the pointer and we reset the pointer in the source object. And this would make our objects safer to work with. Okay, this is how our invalidate method looks. It is going to reset the mItems pointer. It is going to reset the size and the capacity. And our object that we have stolen from is going to become a virgin object, which doesn't really have anything inside. And when time comes for it to die, it is going to die alone. It's not going to take the data that doesn't belong to it anymore. This is the idea here. But it is possible to steal from an object which is really not a temporary, and we have seen that we can do that through stdmove. So what happens here? We have a box object, box1. We populate it with data. We can print it out as we see here, but we are stealing from object 1 and building another box object as we do on this line here. So what happens to box 1? Well, box 1 is going to be invalidated, so the pointers in box 1 are going to be invalidated. Its size is going to be reset to 0, its capacity is going to be reset to 0. And if we go down here, we're going to see that the data has moved in box 2, and box 1 is going to effectively be a shell object, which doesn't contain anything. But the idea I want to convey here is that because our move semantics are resetting pointers in source objects or objects that we steal from, the source objects are safer to use now. We can go in box 1 and start adding other data and really reuse it if we want to do that in our program. And that's going to work really well. This is the idea I want to convey here. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is invalidate pointers after stdmove. We're going to grab the code from the last lecture because we're going to be building on top of that. So let's do that. We're going to put in our files and we are going to open this little boy in Visual Studio Code by dragging and dropping here. We're going to have our code. The box container class doesn't need any change. What we are going to do is hop over in the main function here. We can remove all we don't need here. Let's leave in the populate box function here. And we can take out everything we have in the main function. We are going to create a box container object, box1 here, and steal from it to build box2 as we saw in the slides. And we're going to see how this works out. So we are going to steal from box1 and build box2 at line 19 here. And this is the meat of this example here. After we do this, we're going to see that the data we had in box1 is going to move into box2. And box1 is going to become a shell object. The situation we will have is something like this. So if we have, for example, box1 on top here and box2 down below, and we happen to have had some data in box1, let's say we have some things inside, and in box2 we don't really have anything, we just have a pointer to some data which really isn't pointing anywhere yet. When we do the stealing we are doing on line 19 here, we are effectively going to make the pointer in box2 point to the data we have in box1. So the data is going to move from box1 and it's going to be effectively in box2. And box1 is going to become a shell object which doesn't contain anything. This is what we are achieving with the setup we are doing in this example here. So if we go down and print box 2, we're going to see that we have the data we had in box 1. If we try to print box 1, we're going to see that it's going to be empty. The size is going to be 0. The capacity is going to be 0. And it's not going to have any element inside because of the invalidation we did through our invalidate method. Let's see if I can find it. It is right here on line 35 in our box container class. So let's try and build this example. We're going to pass this through our favorite compiler. I am going to use GCC. The build is going to be good, so this is a good sign. We can bring up a terminal window. And if we clear and run Rooster, we're going to see that we're going to populate box 1 with data. And we're going to put the data in here. You see, this is box 1. And after we steal from box 1 to build box 2, you're going to see that the data has moved in box 2. And if we try to print box 1 after the stealing, we're going to see that it is going to be empty. It won't have any item inside, and the size is going to be 0. The capacity is going to be 0. This is what we achieved with the stealing we did here, because this call here would call our move constructor to move data from box 1 and put the data in box 2. This is what I wanted to convey here. So you need to be careful with the objects you steal from and make sure you leave them in a state that is not going to confuse whoever is working with your program. So because we have reset this box correctly, we can go in and try to work with it. For example, we can go in box 1 and add some data. For example, we can put in a 34 and we can say box 1 and add, let's put in a 4, why not? And if we try to print what we have in box 1 now, let's see what we get. Let's go on top and put in a separator to be able to follow these things easily on the terminal. And if we build now, we're going to pass this through our compiler. The build is going to be good, so let's see what we have. We're going to run, and after our separator here, you're going to see that box 1 is going to expand to 5 because we didn't have enough capacity, and it is going to grow to have a capacity of 5. We're going to add our items. You're going to see that we have 2 items inside. The capacity is 5, and this is the content. You see that we can reuse our box container that we had stolen from previously, and this is going to work really well. If you need this kind of setup, you can use it in your C++ program. This is all I had to share in this lecture. The main idea is that you should really be careful. If you steal from an object, make sure you leave it in a state that is not going to confuse whoever is working with your code at a later time. We are going to stop here in this lecture. In the next one, we're going to learn about move-only types. Go ahead and finish up here and meet me there.